battery. We look onto galvanic cell. Galvanic cell, what make electron flow? This electron flowing because of you have an anode and cathode. Anode, more reactive metal, cathode, less reactive metal, and electron flow because of these two metals. If we look onto the battery, batteries are under the same principle to make electron flow. Now you look onto a battery carefully. Battery is made of also an anode and a cathode. The anode more reactive, cathode less reactive, and this make the electron flow. Battery have an advantage over galvanic cell. As galvanic cell, inside the electrolyte are liquid, so they are not very portable. You can spill. And battery, they are solid. They are not liquid, but rather they are solid or paste inside. So you will not knock over a battery and spill the battery. So you make the carrying very handy, easy to carry, quite portable. And that's why it's also called dry cell. Battery. Actually, you can call it a galvanic cell. There is two types. One is called a primary battery. It cannot be recharged. Primary battery, once you use up, you throw it in the bin. Secondary battery, rechargeable. You use up, you just recharge it and use over again. I'm going to start off with the primary battery now. Of a battery, first, you realize they also have an anode and a cathode. Anode negative, cathode positive. Please remember. Anode is made of zinc. Cathode is made of MnO2. Why they choosing these two material? Reason. If you look onto zinc are highly reactive. They are on the upper reactive group. Then your next question will ask, why not choosing something even higher? Yes, you can choose something even more reactive, but keep in mind, I'm going to use it once and I'm going to throw away. So I will prefer something plentiful and cheap. Zinc satisfies this criteria. They are plentiful, yet they are very reactive. Now look onto MnO2. MnO2 for the year 12 standard reduction potential, I only can find something similar, which is a MnO4, but it will be very similar. The MnO4 or MnO2, what's special about it? They are a metal oxide. What's metal oxide? A rusted metal. Rusted metal, that means you dig from the ground, it's very easy to process it. You don't need to make it into pure. Half rusted metal is quite easy to process. So in the other word, they are cheap and plentiful as well. And when these two combination, we try to make a maximum distance, because the bigger the distance, the stronger is the flow of electron. So zinc and MnO2 it gives quite a good flow of electron. Now look onto the formula. The formula will look very complex, but let's examine the oxidation state. Now, would you be able to identify which ones oxidized and which one reduced? And once you identify zinc oxidized, Mn reduced, now you can split it in oxidation and reduction, anode and cathode. So, anode, zinc flow from 0 become +2. Cathode, MnO2 become Mn2O3. It flow from +4 become +3, reduced. So, once you split it, you will be able to obtain the electromotive force value, the V value. And by adding up the number, it gives you 1.48 voltage. That means this is a strong flow, and it gives it a good flowing of electron. It used for torch, portable radio, or some toys. Of this battery, it does have a disadvantage. Look at the electrolyte, ammonium chloride. This ammonium chloride is a paste. That means good that they are not liquid, but they also have a disadvantage. Ammonium is acidic. Acidic ammonium will attack the zinc coating, so you have relatively short shelf life because this acid ammonium ion will corrode the zinc. Acid react with metal, form metal oxide, or will form salt, and this will cause the cell deteriorate and leak. And you say, oh, the battery is not expensive, but if you put it into your camera and it leak to your camera, and your camera will be damaged. So they only use this type of battery for something cheaper like a torch or simple toy. Secondary battery. Secondary battery, which is a rechargeable. I'm choosing a car battery to demonstrate. Car battery is also called lead acid battery. Why it have this name? Look what's inside. Inside of a car battery, they make from lead, have the lead plate called Pb or PbO2. Why you call acid? And the solution electrolyte is sulfuric acid. Outside of the case is plastic. Acid does not corrode plastic, so it is safe. Of the plate, the negative anode plate are a spongy metallic lead. The positive cathode plate are a brown lead dioxide, PbO2. Solution, the electrolyte, sulfuric acid, high concentrate. Now let's see how this battery works. When the time is discharged, but before we do, please notice 3 oxidation state of Pb. PbO2 oxidation state plus 4. PbSO4 plus 2. Pb 0. Now let's start. In anode, they made of Pb. Cathode made of PbO2. In electron point of view, what does that mean? Pb is 0 oxidation state. PbO2 plus 4 state means Pb have a lot of electron. PbO2 plus 4 means they lack 4 electron. So one is plenty of electron, another is lack of electron, and this causing electron high imbalance. So electron flow. So it gives because of this electron flow. And when it flow, until it flow to reach PbSO4. Now they both plus 2 in oxidation state. And once they reach that, it stops. So the battery is run flat. No more power. Now let's look on to the formula. Look at anode. Pb become PbSO4. Look at cathode. Cathode, PbO2 also become PbSO4. If I add these two equations together, become Pb plus PbO2 become 2 PbSO4. Now let's simplify this equation. Pb become PbSO4. PbO2 also become PbSO4. So you can see the overall equation. They all Pb plus PbO2 become 2 PbSO4. Now, student, please understand this oxidation state change, because this will help you to determine which ones oxidize, which ones reduced, which one is anode, and which one is cathode. Now, when it comes to reversing, you power by the motor which generate power to push this PbSO4 back into Pb for anode and PbO2 as cathode. And now this reverse and it can start all over again. Summary.